Hello everyone, today we'll be discussing on X-ray films and accessories. Dental X-ray film. They serve as a recording medium or image receptor. What is an image? Image is in a picture or likeness of an object, and receptors refers to something that responds to a stimulus, that is energy, in the form of X-ray radiation or light. The film basically composed of four basic components, that is film base, adhesive layer, film emulsion and a protective layer. The base of the film is composed of polyester polyethylene terephthalate with a thickness of 0.2 mm. The function of the base is to support the emulsion of light sensitive silver halide grains and gelatin. The main requirement for a base is it should be having a proper amount of flexibility to allow ease in handling the film. It should be evenly translucent, should not impart color to the image, and it must be able to withstand exposure to processing solutions without distorting. Coming to the second layer, that is adhesive layer. It is basically a thin layer of adhesive material that covers both sides of film base. It serves to attach the emulsion to the base. Now coming to the emulsion. Emulsion is the most important part of the film, a coating which is attached to both sides of the film by adhesive layer to give the film greater sensitivity to X-ray radiation. It is a homogeneous mixture of gelatin and silver halide crystal. The gelatin is basically made from cattle bone. It is used to suspend and evenly disperse millions of microscopic silver halide crystals over the film base. Coming to the function of emulsion. Emulsion basically acts as a dispersion medium, and during processing it absorbs processing solution and allows the chemical to react with the silver halide crystals. Silver halide crystals, it is sensitive to radiation or light. The halides are basically two types which are present in emulsion, that is silver bromide and silver iodide. Mostly these are silver bromide, that is 80 to 90%. These halide crystals absorb the radiation during X-ray exposure and store the energy from the radiation. Coming to the last layer of the film, that is protective layer. It is a thin transparent coating placed over the emulsion. It protects the emulsion surface from manipulation as well as mechanical and processing damage. It is basically nothing but an additional layer of gelatin added as a super coating to the film emulsion. Coming to the types of dental X-ray film, these are divided into intraoral, extraoral and duplicating. These are also of three types, that is periapical, bitewing and occlusal. These are also classified based on the speed, that is A speed, B speed, C speed, D speed and E speed. These are also classified on the basis of exposure, that is direct exposure films which are directly exposed by X-ray radiation. These are also called as non-screen films, and indirect exposure films which are sensitive to visible light. These are also called as screen films. Based upon the emulsion coating, these are classified into single emulsion and double emulsion. Coming to the intraoral film. The film which is placed inside the mouth during X-ray exposure is intraoral film. The basic component of intraoral film is, the first one is paper film wrapper, which is a protective sheet. Then there will be a lead foil sheet. It is positioned behind the film to shield the film from back scattering radiation that results in film fog. It also absorbs residual beam. Then the third one is outer package wrapping, which is soft vinyl or paper wrapper that hermetically seals the film packet, protective back paper and lead foil sheet. The outer wrapper has two sides, that is label side and the tube side. The tube side is the solid white and raised bump. When placed in the mouth, it faces the teeth and the tube head. And the label side, it has a flap that is used to open the film packet. So this is an example of intraoral film. There are basically three types of intraoral film, that is periapical, bitewing and occlusal. The periapical film is indicated to examine the entire tooth and supporting bone, with the sizes is 0, 1 and 2. 0 is 22 into 35 mm, 1 is 24 into 40 mm and 2 is 31 into 41 mm. So these are the various intraoral films. Coming to the bitewing film, the main indication is to examine the crown of both maxillary and mandibular teeth on one film. It is used for the detection of initial interproximal decay, secondary decay and interproximal overhanging restoration. It is also used for the assessment of periodontal disease, subgingival calculus and to check the extension of crown margins. The film which is used in adult it is basically size 2, and in children it is used the film which is used is size 1 or size 0. Coming to the occlusal film, the size of the occlusal film is 57 into 76 millimeter. The duplicating films are a type of photographic film that is used to make an identical copy of an intraoral or extraoral radiograph. It does not require exposure to the X-ray, and the special equipment and duplicating films are necessary for the duplication process. The film has an emulsion only on the one side. Coming to the next heading, that is grids. The grids are basically nothing. These are the sometimes the scattered radiation originating within the patient tissue travel in different directions than the primary beam and causes deleterious effects in the film, which is called as film fogging. So a grid is basically used to prevent the scattered radiation from reaching the film. Accordingly, the grid is positioned between the object and the film, and it consists of large number of long parallel strips of radio opaque material which is interspread with radiolucent material, mostly plastic. The radio opaque material is mostly lead. The lead strips of the grid absorb most of its scattered radiation. However, some of the scattered photons that travel in the same plane as the primary beam may contribute to the formation of the image. What is grid ratio? It refers to the ratio of thickness of the grid to the width of the radiolucent interspacer, where H is the thickness of the lead strip and D is their separation. The usual thickness of lead strip is 0.005 to 0.008 centimeter. Coming to the types of grid. The linear grid. In the linear grid, the strips of lead are placed parallel to each other. In the focused grid, the lead strips are angled from center to the edge so that the interspaces are directed at the focal spot. Then there will be a grid that is pseudo-focused grid. The extra reduction of primary radiation away from the center of the beam can be minimized by using a pseudo-focus grid in which the height of the lead strip are progressively reduced from the center to the periphery. Then the cross grid. In this, the two grids are placed on top of each other and at right angles. This minimizes the scattered radiation traversing in the same line as the primary beam. Then the last one is the moving grid or Bucky grid. The use of moving grid reduces the radiolucent grid lines in the radiographic image. So this is achieved by moving the grid sideways during the exposure. As you can see in this picture, linear grid, the lead strips are arranged parallel. In the cross grid, these are at right angle to each other. In the focus, these are slightly angled. Coming to the next, that is intensifying screen. These are the screen which make use of principle of fluorescence, that is the emission of visible light. There are certain inorganic salts or phosphors, mostly magnesium oxide or titanium dioxide or calcium tungstate, which have the property of absorbing X-ray photons and emitting visible light. So these salts are incorporated into intensifying screens and used along with the X-ray film. An intensifying screen and a film combination makes the image receptor system 10 to 60 times more sensitive than when the film is used alone. Thus, the use of intensifying screen considerably reduces the radiation exposure to the patient. The ideal requirement of the fluorescent material is the material should absorb a greater amount of X-rays, the material should have a moderately high atomic number, the material should emit a large amount of light of a suitable energy and color, and there should not be any afterglow which can adversely affect the image quality. The various phosphors which are used are calcium tungstate, zinc sulfide, cadmium sulfide, barium lead sulfate or terbium activated gadolinium oxysulfide or thallium activated lanthanum oxybromide. Among these, the calcium tungstate was the most commonly used phosphor. Coming to the composition of intensifying screen, an intensifying screen has the following layers, that is base, reflecting layer, phosphor layer and coat. The base of intensifying screen is made up of polyester plastic having a thickness of 0.25 mm. The reflecting layer is usually made up of titanium dioxide. It reflects the light emitted by the phosphor layer to the X-ray film back. It lies below the phosphor layer. The phosphor layer is the layer where various phosphors used are mentioned. The rare earth intensifying screens are about 4 times more efficient than calcium tungstate. Intensifying screens, so special X-ray films sensitive to green light are required while using green emitting intensifying screens. Coming to the last layer, that is protective coat, which is made up of plastic having a thickness of 8 micrometer over the phosphor layer. and this layer can be cleaned. The intensifying screen should be kept clean without any debris, spots or scratches. Otherwise, these areas will result in underexposed or light areas in the image. Coming to the advantages of intensifying screen, they basically decrease the exposure time and increases the tube life. They decrease in patient exposure to the radiation. The disadvantages are it reduces the contrast, it decreases the sharpness and resolution, and it requires expensive equipment. Coming to the cassette, a cassette is a flat box used for transporting a film and which holds the intensifying screen and the film in close contact. The main function of a cassette is to maintain the film in close contact with the screen during exposure. It prevents the light exposure. It protects the intensifying screen from physical damage. A cassette generally consists of two rectangular plates which are held together by hinges on a long edge. It has a front side which faces the X-ray tube and a back side which is kept away from the tube. Coming to the types of cassette, first is rigid cassette. As the name implies, it cannot be folded or bent. Then the curved cassette. A curved cassette is used to achieve a parallel relationship between the subjects and the film in certain anatomical regions with curvature. Then the gridded cassettes. A gridded cassette contains an incorporated grid at the front of it. Then the flexible cassette. A flexible cassette is used for the adaptation to rounded surfaces. A flexible cassette is made up of plastic. It has main application in OPG.